Hello everyone, my name is Abhijith PA. I am from Government Engineering College Idukki. I am a third year Electronics and Communication Engineering student. Today I am going to talk about the CPU architecture of ARM9 processor. ARM9 is a group of older 32-bit RISC ARM processor cores. It's used for microcontrollers. ARM9 core family consists of ARM9TDMI, ARM940T, ARM9ES, ARM966ES, ARM920T, etc. I'm going to take ARM9TDMI CPU architecture. ARM9TDMI is introduced in 1998. It's a successor to the popular ARM7 TDMI core. Now I am going to talk about some features of ARM architecture. The ARM9 TDMI is a member of ARM family of general purpose microprocessors. It is targeted at embedded control applications where high performance, low die size and low power are important. The ARM9 TDMI supports both the 32-bit ARM and 16-bit thumb instruction sets, allowing the users to trade off between high performance and high code density. The ARM9 TDMI supports ARM debug architecture, and it includes logic to assist in both hardware and software debug. The ARM9 TDMI supports both bidirectional and unidirectional connection to external memory systems. The ARM9 TDMI also includes support for coprocessors. The ARM9 TDMI processor core is implemented using a 5-stage pipeline consisting of fetch, decode, execute, memory, and write stages. The device has a Harvard architecture, and the simple bus interface eases connection to either a cached or SRAM based memory system. The figure shows the CPU architecture of ARM9 processor. These are the main parts of CPU of ARM processor: register file, booth multiplier, barrel shifter, arithmetic logic unit, and control unit. Speaking of registers, the processor has a 37 registers made up of 31 general 32-bit registers and 6 status registers. At any one time, 6 general registers R0 to R15 and 1 or 2 status registers are visible to the programmer. The visible registers depend on the processor mode. In all modes, 16 registers R0 to R15 are directly accessible. All registers except R15 are general purpose and may be used to hold data or address values. Register R15 holds the program controller. A 17th register, the CPSR, which means control program status register, is also accessible. It contains condition, code flags, and the current mode bit and may be thought of an extension to PC. R14 is used as the subroutine link register and receives a copy of R15 when a branch and link instruction is executed. Program status register contains the processor flags Z, S, V, and C. The mode bits also exist in the program status register in addition to the interrupt and fast interrupt disable bits. Some registers are used like the instruction registers, memory data, read and write register, and memory address register. Barrel shifter. The barrel shifter has a 32-bit input to be shifted. The input is coming from the register file or it could be immediate data. The shifter has other control inputs coming from instruction register. Shift field in the instruction controls the operation of the barrel shifter. This field indicates the type of shift to be performed. Example: logic left or right, arithmetic right or rotate right. The amount by which the register should be shifted is contained in an immediate field in the instruction, or it could be lower 6 bits of a register in the register file. Booth multiplier. The multiplier has 3 32-bit inputs. All the input come from the register file. The multiplier output is only the 32 least significant bits of the product. ALU or arithmetic logic unit. The ALU has two 32-bit inputs. The first comes from the register file, while the other comes from the shifter. ALU outputs modify the status register flags. The control unit. For any microprocessor, control unit is the heart of the system. It is responsible for the system operation, so the control unit design is the most important part in the whole design. Control unit is usually a pure combination circuit. The processor timing is also included in the control unit. Pipeline implementation of the ARM9 processor. The ARM9 TDMI implementations uses a 5-stage pipeline design. These 5 stages are instruction fetch F, instruction decode D, execute E, data memory access M, and register write W. This figure shows the 5-stage pipeline operation of ARM9 processor. That's all about the CPU architecture of ARM9 processor. Thank you.